Introduction to sequences and series. A sequence is an ordered list of numbers called terms. It can be infinite, which means unending, or finite, which means it ends. The explicit formula defines the nth term or the general term. Let's look at a couple examples. If we're given the formula for the nth term of the sequence, we need to be able to write the first four terms beginning with n equal to 1. So what this means is that when we're given a formula, this is written with the nth term in mind. We want to start with n equal to 1 and write the first four terms. So a sub 1 is the number when we substitute 1 for n. When we simplify this, we're going to get a sub 1 is equal to 1. A sub 2 is the number we get when we substitute in 2 for n. And when we simplify, a sub 2 will give us 5. A sub 3 is the number we get when we substitute in 3 for n. And when you simplify, we'll get a sub 3 is equal to 9. And then lastly, a sub 4 is the number we get when we substitute 4 in for n. And when we simplify, we will get a sub 4 is equal to 13. So the first four terms, we can write them as 1, 5, 9, and 13. This would be our final answer. I want you to go ahead and pause, try example 2, and check back with me when you're finished. Hopefully your first four terms are negative 5, negative 32, negative 243, and negative 1024. Now these problems ask us to write the next term in the sequence, then write a rule for the nth term. So what that means is we're going to look at our list of numbers and look at the pattern and predict what the next number is going to be. Then we want to write a rule or a formula so that we can find any number in that sequence. So these are the two things that we're going to be looking for. Now, to help us figure it out, let's start by numbering our terms. This is our first term, our second term, our third term, our fourth term, and our fifth term. So the next term in the sequence is going to be our sixth term. Now, all of our numbers are fractions, so our next one is also going to be a fraction. In the denominator, we have a 3, so this is also going to be a 3. So we just have to figure out the pattern with the numerator. 1, 2, 3, 4, 5. So next comes 6. Now, when we're trying to figure out our formula for the nth term, we know it's going to be a fraction, and again, we know the denominator is going to be 3. So we just have to figure out how to write the numerator in terms of n. So if our first term has a numerator of 1, our second term has a numerator of 2, it follows in that pattern where our term number is the same as our numerator. So if we want to know what our nth term is, we just have to substitute that number n for our numerator. So here's our rule. A sub n, any term in the sequence, can be found by putting in that term number for our numerator over 3. Now I want you to try example 2 and example 3 and check back with me when you're finished. So for example 2, hopefully you started off the same way. N is equal to 1, 2, 3, 4. And then for our fifth term, we know it should be negative because all of our numbers are negative. It should be a fraction with 1 in the top. And then our denominators are going 2, 4, 6, 8, 10. Now writing a rule for the nth term, again, it's always going to be negative. It's always going to be a fraction with the 1 on the top. So to represent the denominator, we need to figure out the relationship between the term number and the number itself. So 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, and 4 times 2 is 8. So we take the term number and we're always going to multiply it by 2. Now I wanted to walk through example 3 with you because it's a little trickier. So let's start again by writing the term numbers. And then let's go ahead and try to guess that fifth term. So we're counting 1, 3, 5, 7, which are our odd numbers, so our next number should be 9. That part wasn't so bad, but writing the rule for the nth term is a little trickier. Term number 1 is 1. Term number 2 is 3, which is 1 more than 2. Term number 3 is 5, which is 2 more than 3. Term number 4 is 7, which is 3 more than 4. So we don't have a consistent pattern, so we need to try something else and be a little more creative. If we take our term number and multiply it by 2, we're going to get 2. If we subtract 1, we'll get 1, which is the term. So let's take our next term number, 2, and follow that same pattern. Multiply by 2, we'll get 4, then subtract 1. We get 3, which is our next term number. So let's try it again. Our term number 3 multiplied by 2, subtract 1, and we get our term number. One more time. Term number 4 multiplied by 2, subtract 1, and then we get our next term. So if we take our term number multiplied by 2 and subtract 1, this is our rule that represents our nth term. A series is the indicated sum or addition of all terms of a sequence. The summation notation uses the Greek letter sigma. So basically, the sequences we worked with before, we're going to take all of the terms from the first to a certain term and add them all together. Now, it's represented by a formula, that nth term that we talked about, and it tells us which term to start with and which term to finish with. So let's go ahead and take a look at this example as we explore how to work with a series. So this tells us that we are going to add up all the terms from k equals 1 up to k equals 4 using the formula for the nth term 2k. So this equals what happens when we take 1 substituted in for k, and then we're going to add 2 substituted in for k, then add 3 substituted in for k, all the way up until we hit 4 substituted in for k. So this is really 2 plus 4 plus 6 plus 8, which is going to be equal to 20 as our final answer. In these examples, we want to write the series in summation notation, beginning with k equal to 1. So first let's go ahead and count our terms. We're going to use the variable k to represent our first term, second term, third term, and fourth term. So we're adding the first 4 terms of the sequence. So we're going to start off with our sigma, starting with k equal to 1, all the way up to our fourth term. Now the last thing we need is our formula for the nth term. So we're going to find the formula looking at the pattern of numbers the same way we did with our sequence. So if you notice, our numbers are fractions. We have a 1 in the numerator. And if you look at the denominators, these are all powers of 4. 4 to the first power is 4. 4 to the second power is 16. 4 to the third power is 64. And 4 to the fourth power is 256. So our denominator is represented by 4 to whatever term power it is. So we're going to put 1 over 4 to the k to represent our formula for the nth term. And there's our answer. Now, before you try example 2 on your own, let me give you a little hint. Look back at your notes at example 3 when we were writing the rule for the nth term. It's very similar to that one, but slightly different. See if you can figure it out and check back with me when you're finished. So first you should have labeled how many terms you have. We have from the first to the sixth term. So k equals 1, that's where we started, up to k equals 6. Then, if you look at the pattern of numbers, again, we're counting in order of our odds, except this time we're starting with 3 instead of 1 like we did last time. So, if you take the term number, multiply it by 2, and this time add 1, you're going to get the number in the sequence. So if you follow that pattern, it gives us our rule for the nth term is 2 times k, the term number, plus 1. I hope you got that right, even though it was a little tricky. That's it for this set of notes on our introduction to sequences and series.